Okay, so we have the homework 3.1.2. All right, let's read through it. Out of 20 contestants, 10 are girls. Okay, so just for my sanity, I'm going to write here, there's 10 girls. That means there's 10 boys, and there's 20 total. Okay. What is the probability that the first contestant is a girl? 10 over 20, which is 1/2, which is 50%, which is 0.5. Okay. And by the way, I encourage you to try the problem first, and then your job is to check it to make sure. If all you're doing is copying my answers, you're not going to do well on the test. Probability is kind of difficult. All right, they want to know the probability. So this was just the probability of a girl. This is probability of a girl and then another girl. So you got a 50% shot the first time. You got a 50% shot the second time. So 1 times 1 is 1, 2 times 2 is 4, 1/4 is 25%, which is 0.25. So you have a 25% chance that both times you'll pick girls. What is the probability that the second contestant is a girl independent of the first? Is the independent? Yes, because this one doesn't affect this one, so the answer is yes. All right. Okay, let's see. So I'm going to have to read this. The locker. There's one locker that all the kids dread. So there's one locker that they dread. The locker number is 831. It's supposed to be haunted. He knows there's 535 lockers left. So there's 535 lockers, and one of them is bad. Okay? So they want to know what's the probability that he reaches in and pulls, the bad one. Okay? Well, there's only one bad one out of 535. And if I get my calculator, that's a really small percentage. I don't know that one in my head. So clear 1 divided by 535. And that's, wow, that would be 0%. So it's like 0.1% chance that it happens. Okay? So maybe even actually I should say not 0.1, let's round it and say 0.2 chance. That means that's 0.002 because you move it over twice. So there's not really a big chance that it's going to happen. So should he be worried? No, it's less than 0.5%. Okay? So it's less than 0.5%. I wouldn't worry about something like that, the chance of it happening. Okay? All right, let's see. So we've got money. We got 3 coins. We've got a penny, a nickel, and a dime. So what would be better to represent your sample space? A list, a tree diagram, or area model. Honestly, area model with 3 coins, I can't do that. I can only do an area model when I have 2 options. Okay, so, actually, no, I can't. I can do that 3 by 3. But honestly, area model is hard for me. I think making a list is the easiest one for me. Whatever you want, but I'm going to do it. So when they ask for the sample space, that means they want to know what are all the options. Okay, so here's a penny, and then nickel, and then dime, and then the penny can either be heads or tails. The nickel can either be heads or tails, and the dime can be heads or tails. Okay, so let me do my little sample space: penny, nickel, dime. I know I'm not going to have enough space here. So if we're doing penny, nickel, dime, options are heads, 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 tails, or tails, tails, tails. I could do that. I really should have made more space here. Sorry. Heads, heads, tails. Let me go up here. You know what? I'm going to get new paper because this is just not going to fit. So pennies, nickels, dimes. Okay, so we had heads, 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 tails, tails, tails. All right, so I'm going to go heads, tails, tails. So I'm going to do 1 head and 2 tails. Let me tails, heads, tails, 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 heads. See how I did that methodically? That way I don't forget. Now I'll do 1 head. 1 tail. So now I'll go tail, head, head. Heads, tails, heads, and tails. And then tails, heads, heads. Okay, let's see. I think that covers all of it. 1, 2, 3, 4, 5, 6, 7, 8. And by the way, I actually knew there were 8 because I have 2 options here, and I have 2 options here, and I have 2 options here. And 2 times 2 is 4, times 2 is 8. So I know there's a total of 8 of them. Okay, so they want to know what's the probability of getting 3 heads. So there's 1. I don't see any other option. So that would be 1 out of 8. And just to teach you percent and decimal, 1 divided by 8 is 0.125, so that's about 12%. So we'll say about 13% or about 0.13. All right, this time they want 1 head and 2 tails. So 1 head, 2 tails, 1 head, 2 tails, 1 head, 2 tails. That's 3 out of 8. Now, if I was figuring out the percentage, I could use my calculator, or I could go, if 1 out of 8 is 13%, I can do 3 of those. That would be about 39%. And then that would be about 0.13. So let's see if I'm right. 3 divided by 8, 37. I was close, 38. Okay, so we'll say 38. Just, oops. But we're estimating here, remember? Okay, at least 1 tail. So at least 1 tail means he needs to have 1 tail, 2 tails, or 3 tails, okay? And literally all of them have tails except for this one right here. So that would be 7 out of 8. So remember how I said I could multiply this by 7? But why would I do that when I know that if this is 1 out of 8, and this is 7 out of 8, and 1 out of 8 plus 7 over 8 is 8 over 8, which is 100%. Let's do something called the complement, which you'll learn later, and it means find everything that's not. So just go 100% minus 13% is about 87%, which is about 0.87. Okay, last one is exactly 2 tails. So I got to find exactly 2 tails. So that's this one, and this one. And that means that's 3 out of 8. Okay, which is more likely, flipping at least 2 heads or at least 2 tails? Well, at least 2 heads and at least 2 tails, if it's a 50% shot, it's exactly the same amount because heads and tails are the same thing. Okay, let's turn the page. All right, what do they want you to do here? They want you to see if this is a possible triangle. Well, I know that this needs to be the longest side, and it's not, so this is not possible, okay? I could also show that 6 squared plus 12 squared, see if that equals 11 squared. 36 plus 144, does that equal 121? And it doesn't, okay? This one, this plus this, needs to add up to equal 180. So let me get my calculator. 119 plus 42 plus 26, and I get 187, and that does not equal 180, so that's also not possible. It doesn't exist. All right, multiply. So we're going to make a box. It doesn't matter if you put x plus 5 here, x plus 5 here, x plus 5 here, or x plus 5 here. My brain just puts it here. It doesn't matter if you put 3x plus 2 here or 3x plus 2 here, but you can't put it here because this is the x plus 5. So I'll go 3x plus 2, multiply. 3x times x, 3x squared. X times 2, 2x. 3x times 5, 15x. 5 times 2, 10. These two are the same. Add them up. I get 3x squared plus 17x plus 10. All right, this one, instead of just having 1, 2, it's got 1, 2, 3. So I've got to separate it like that. So y minus 6, 2x plus 3y minus 4. 2x times y is 2xy. Let me zoom this one in a little bit because that one's more difficult. 3y times y is 3y squared. Negative 4 times y is negative 4y. Negative 6 times 2x is negative 12x. Negative 6 times 3y is negative 18y. And negative 6 times negative 4 is positive 24. Now let's look and see. Usually the diagonals are supposed to be the same, but since there's x's and y's, it's weird. So these diagonals are not the same, but these diagonals are the same. So I'll just put it in order. 2xy plus 3y squared minus 12x minus 22y plus 24. Okay? All right. This one, they want to know if this triangle is congruent to this one. So I better go 180 minus 65 plus 75, and I'll figure out that third side. So 65 plus 75 is 140. 180, minus 140 is 40, so that's 40 degrees. Figure out this one. Let's see, we got 40, 65. Let me stop this. So we get 75, 65, 40. So yes, that means that triangle ABC is congruent to triangle. Let's see, A is the 40, so X is the 40. B is the 75, so Z is the 75, and then that means that's Y. Okay, the next one. So 180 minus 75 plus 50. So 75 plus 50 is 125, minus 180 is 55. No, that's not the same. This is 75 and 40, so 180, 75 plus 40 is 115. So that would not work, so that one is also a no. And that's your homework. Hopefully it helped.